So I've got, what's going on here? I've got a parabola that has a y-intercept of 16, and it crosses the x-axis at, so what do we got, 16 minus x to the fourth equals 0, so that would be 16 equals x to the fourth, and the fourth root of 16 is 2, but it could be negative 2 also, so positive 2 to negative 2. And we know, fourth degree equations look like a parabola, they just kind of flattened out a little bit, so we're not going to worry too much about that. Greatest possible areas, we're embedding a rectangle in here. And we know the coordinates of that vertex is going to be x, and then if we drop that x into the equation, we're going to get 16 minus x to the fourth. Okay, so there's x, there's y. And we know the dimensions, the area. What are we trying to do? We're going to try to greatest possible area. So we're going to try to maximize the area of this rectangle. Of course, you got to remember that if it's x long over here, it's x long over here, and that makes that whole rectangle 2x wide. So, and the height of it is the 16 minus x to the fourth. So we're going to find an area of a rectangle that's 2x by 16 minus x to the fourth. And we could certainly do some algebra with this. At this point, I think it's good enough. Shortly in calculus, you can learn how to do this in a much easier manner. So we won't worry so much about doing the algebra right now for this in a pre-calculus kind of model. If it's a quadratic, no problem. That would be easy. But a fifth degree actually, if you distribute that through. So let's go use some technology to figure this out. So I could use a graphing calculator. I chose to go out to Desmos just because I can screen capture it a lot easier for these videos. So there's the area function, and we're talking about x, so how far from the x-axis. We certainly don't care about negative x values. We're really only concerned about this part of the function here, that on that domain. And I'm seeing a maximum. Remember, this is the area function. We're seeing a graph of the area, and this is where that's the highest, right here. So that tells me when I'm, so let's see, I've got negative 2 to positive 2, and I've got 16, and here's that graph. And if I come out to 1 point, let's see, eyeball this, 1.37, and of course my drawing is probably not doing it justice. That dimension, when that is the x value, and of course it would be negative over here too, that's going to have the maximum area. Okay, and next semester when you do calculus and learn about taking derivatives, you'll see that this is true. And that's how I do this kind of problem.